Section 3.1 is on page 166, Introduction to Determinants. Given a matrix, A sub 1, 1, you know what? Let's just make it really quick. A, B, C, D. This is a 2 by 2. If I want to find the determinant of matrix A, which is a 2 by 2, it's simply the cross product. It has to be in that order. AD minus BC. And the determinant is really denoted by like an absolute value of A, or simply the magnitude of A for vectors. That's the notation. So this is the notation for a matrix. This is the notation for determinant. Now, for a 3 by 3, a 4 by 5, a 5 by 5, what you really have to worry about are cofactors and minors. It's not that challenging. Associated with any square matrix. So if I take A to be, let's say, A, B, C, D, E, F, G, H, I, associated with this is a list of signs. You always start with a positive. You want 3 by 3. Make the diagonal positive every time. And when you move in both directions, you should never have two signs that are the same side by side in any order. The diagonal, which is this, is always positive. This is called, these are the cofactors. And if I'm looking at a matrix that's a 4 by 4, the cofactors will be a positive, negative, positive, negative. Again, remember, there are no two identical signs, vertical or horizontal, and the diagonal must always be positive. That kind of helps a lot. And here that's a minus, plus, minus. There we go. Diagonal will always be 0. Diagonal will always be positive, I'm sorry. Now the catch is, these are the cofactors. Oh, I did write that down. The minors. What you do, you reduce a 2 by 2, a 3 by 3 to a 2 by 2. The minors, meaning, if you pick this row, if you picked A, the minors of, if you picked A, then you cross A's row and column, and you have E, F, H, I, and you find the product of those two, because that's 2 by 2. So if you wanted to pick I, you cross I's row and column, that reduce it, and that's how you do 2 by 2, 3 by 3. You start reducing that till you come down all the way to a 2 by 2. 3 by 3 has a shortcut. I'll show you that. So let's talk about a couple of examples and get those out of the way. So 1 through 8, use a cofactor expansion across the first row. A cofactor expansion across the first row. There's the first row. To do this, I need to match with the first row. So positive times a positive is a positive 1. And if I cross everything in one's row and column, I'm left with a 2 by 2. So if I cross a row and column, I have 1, 1, 4, 2. If I get to the second piece, negative times a positive is a negative, and if I cross its row and column, I'm left with 3, 1, 2, 2. And if I get to the 4 times a positive, that's a positive 4. And cross 4's row and column, I'm left with 3, 1, 2, 4. We did this back in the days, you called it cross product, but you took the cross product across the first row every time. And do you remember when you did the I, j, and k, you always multiply this by a minus? Can you see why? Remember I, j, k, and we listed the two vectors, and we did the cross product, the I component, j and k. We just did this across the first row every single time, and then you work this out. That is a 2 minus 4 minus 2 times 6 minus 2 plus 4 times 12 minus 2. So that is a negative 2 minus 2 times 4 plus 4 times 10. That is negative 2 minus 8 plus 40. That is 30. No matter which row or column you pick, the determinant will be an actual 30. Then it says, also compute the determinant by cofactor expansion down the second column. Alright, let's do the second column. I love this. It doesn't register. Here we go. Got it. So if I want to do the same thing, and I want to use the second column, well, second column is right there. Well, there it is. So if I decided to use the second column, again, there's no wrong way of doing this. Any way you like. It's going to be 2. And if I cross a row and column, 3, 1, 2, 2. And if I take positive times a positive is a positive 1, cross 1's row and column, I'm left with 1, 4, 2, 2. And if I take the last, negative times a positive is a negative. And if I cross its row and column, and I'm going to get a negative 2 times 6 minus 2. That's negative 2 times 4 plus 1 times a 2 minus 8 minus 4 times 1 minus 12. So that's plus a negative 6 minus 4 times negative 11. I'm getting a negative 8 minus 6 plus 44. I'm getting negative 14 plus 44, which is a 30. Again, you can't get it wrong, no matter how you do it. So again, a good practice. Now I'm going to ignore directions just to point out one thing. If I saw one of those and I had a chance to pick, and most of the time you get to choose, messed up, I should choose the row or the column with the 0 because that saves me work. So to do this quickly, either you should pick column 1 or row 2. To pick column 1, that would be a 5, 3, negative 3, negative 4, 7. Plus, no need to worry about 0 because 0 times anything is 0. So that saves you a third of the work. And if you go for a positive times a 2, that's a 2. And cross its row and column. Negative 2, 2, 3, negative 3, and there it is. And that would be a 5 times 21 minus 12. Plus 2 times 6 minus 6, that's a 0. So I'm left with a 5 times, what is that? 21 minus 12, is that a 9? 45. Now the busy work is not really it. The determinant tells us a lot of stuff. If the determinant doesn't equal 0, that means that this is invertible and inverse exists, and that means there's a solution. It has a lot of different meanings. There is a shortcut that I want to show you. And on this problem, it says compute the determinant by cofactor expansion at each step. Choose a row or column that involve the least amount of computation. Well, guess what? Associated with this, so the 0 I ignore, the 0 I ignore. I'm pretty much looking at a -3, and if I cross the row and column of that, I'm left with a -2, 2, 2, -4, 5, 2, 0, 5. If I'm gonna go again, well, the only way to do it is to do it one more time. And again, I should pick either this column or this row. It doesn't matter. If I stick with this row, then it's a -3 times. If I pick this row, +2 times 2. And if I cross its row and column, that's -2, 2, -4, 5. If I take the 0, well, that's just 0. There's no point in worrying about the sign even. And a 5. And if you cross its row and column, that's 1, -2, 2, -4. And you proceed that way. And that would be a -3 times 2 into -10 plus 8 plus 5 into a -4 plus 4. And that would be a -3 times, that is a -2, so that's a -4, that's a 0, so that's a 12. And there it is. It turns out, for a 3 by 3, there's a shortcut. And let me demonstrate. It turns out there's a shortcut for a 3 by 3, and they talk about it in this book. So what you do, you list the first 2 rows, 2 columns one more time. And remember how you find the determinant for a 2 by 2, you cross multiply? Well, guess what? You multiply across. 1 times 3 times 2, that's a 6. Plus, you multiply across. 1 times 3 times 3 is a 9. And you multiply across. 8 times 3 is 24. And do you remember how you subtract this? You would subtract all of those. 3 9 times 4 is 36. 3 times 1 times 1 is a 3. And 2 times 2, 4 plus 3, that's a 12. So that is actually 24. 39 minus, and this is 12, 15. 51. And that's a negative, what is that? 12. And that's a quicker way of finding the determinant. And then keep in mind, the key is not just to find the determinant, the key is to understand how the process is done. Okay, a main theorem that I need you to get out of the way. It says a triangular matrix, remember what a triangular matrix is? Is a matrix with either this being zeros or this being zeros, either or. So glancing at this, this is a triangular matrix. Do you see that? It says a triangular matrix. If a matrix is triangular, then the determinant is the product of the entries on the main diagonal. If you want to find the determinant of this, that's simply 3 times -2 times 3 times -3. I suggest you apply that anywhere you see it in this section. And there's your homework. Again, practice some of those. Ignore directions. Use the shortcut when you can. And use this trick if you can. And that concludes this section.